Welcome to the deep dive. I'm really thrilled you decided to tune in today because we're pointing our lens at a world most of us only ever see from, the other side of a reinforced cockpit door.
Yeah, the passengers definitely don't see this part.
Right. We're taking a rare, just an incredibly detailed look inside the highly structured, exceptionally high-stakes mindset of A320 pilots.
Mm-hmm.
And our mission for this deep dive is to understand exactly how the professionals flying these multi-million-dollar jets are trained to process complex emergencies.
It's really fascinating.
It is. And honestly, the goal isn't just to learn about aviation, right? It's to see what we can learn from how their brains are literally rewired to operate under intense pressure.
I mean, it really operates as a masterclass in psychology.
Yeah.
When you look at the architecture of how these pilots are trained to think, you are looking at a masterclass in human performance limitations.
I noticed that immediately when reading through our source material for today, we're pulling out the most vital insights from an operational document titled Airbus Philosophy, The Logic of Memory and Methodology.
A bit of a dry title.
Right. When I first picked this up, I wondered how dense a manufacturer's philosophy document would be. But it reads almost like a psychological thriller about human error.
It really does.
Okay, let's unpack this. In the Airbus world, abnormal and emergency procedures are strictly classified by the manufacturer as not routine.
Which sounds like a massive understatement.
Yeah, a huge understatement.
Yeah.
But they do that to make a point. They don't just handle unexpected things on the fly or rely on pilot intuition. The entire system logic is fundamentally built around one specific factor.
How much time you have.
Exactly. How much time you have before physics takes over.
What's fascinating here is that this philosophy entirely strips away the myth of the maverick pilot flying by the seat of their pants.
No Top Gun stuff here.
Right, none of that. It is a highly engineered approach to threat management that acknowledges a very uncomfortable truth.
Which is?
That the human brain is deeply unreliable when suddenly flooded with adrenaline.
Yeah.
The people who built the A320, they know exactly how human beings process emergencies. They know our vision narrows, our memory degrades, and we get impulsive.
Just biologically.
Exactly. So they built a methodology to actively protect pilots from their own biological instincts.
And that brings up the first major concept from the document, which serves as the foundation for how A320 pilots operate, like 99% of the time.
Mm-hmm.
The text calls it the textbook answer, or the default mode. It's the read and do procedure.
Read and do.
Right. So if an engine pump fails or a hydraulic sensor goes offline, the pilot doesn't just start flipping switches from memory. They default to read and do.
Always.
But the text splits this default mode into two distinct categories, sensed and not sensed. How does a pilot know which one they're dealing with?
Well, the distinction comes down to how the aircraft itself communicates the failure to the crew.
Okay.
A sensed failure is exactly what it sounds like. The A320's internal computers detect a parameter that is out of bounds, say, an oil pressure drop.
Something measurable.
Right. The aircraft then triggers an automatic presentation on the ECAM.
Which stands for?
That stands for the Electronic Centralized Aircraft Monitor. Think of it as the main diagnostic screens situated right in the center of the instrument panel, directly between the two pilots.
Got it.
The ECAM essentially rings a chime, flashes a master caution or warning light, and populates a specific step-by-step checklist right there on the screen.
So the plane does the diagnosing and hands the crew the solution on a silver platter.
Essentially, yes. The aircraft senses the problem and provides the explicit read and do instructions.
But then we have the not sensed procedures.
Right. These are situations where the aircraft's computers haven't automatically flagged an issue, but human senses do.
Like what?
A classic example would be a strange vibration in the floorboards or the smell of electrical smoke in the cabin. The computer might be blind to it, but the pilots are acutely aware something is wrong.
In that scenario, since the ECAM screen isn't telling them what to do, where do they find their read and do checklist?
They have to manually retrieve it. Depending on the exact aircraft family, they either navigate through specific manual ECAM menus to pull up the relevant procedure, or they physically open a book called the QRH.
The Quick Reference Handbook.
Exactly. They diagnose the symptom, find the corresponding page, and begin the read and do process.
And whether they're reading off the ECAM screen or out of the QRH, the execution follows an incredibly strict management process.
Very strict.
And this is where the source text gets very serious about the stakes, specifically outlining what it calls the rule of irreversible controls.
This is crucial.
The text states that a pilot is strictly forbidden from acting on any irreversible controls without obtaining explicit confirmation from the other pilot.
Yes.
But I need you to translate something for me. The document lists engine fire, push buttons, and thrust levers, which makes total sense to me. But it also lists IR rotary switches. What are those, and why is touching them considered irreversible?
That is a great question, because to a layperson, a rotary switch sounds harmless.
Yeah, it sounds like a volume knob or something.
Right. IR stands for inertial reference. These systems are basically the internal gyroscopes and accelerometers of the aircraft.
Okay.
They tell a plane its attitude, meaning whether it's pointing up, down, or banking, left or right, and they help track its position over the Earth.
So they're vital for navigation.
Absolutely. Before a flight, these systems take several minutes sitting perfectly still on the ground to align and figure out exactly where they are.
Oh, I see where this is going.
Yeah. If a pilot is rushing through a checklist in midair and accidentally reaches up and turns off an IR rotary switch, they instantly blind the aircraft's navigation and attitude sensors. And because the plane is moving at 500 miles an hour, you cannot simply turn the switch back on and wait for it to realign. That data is gone. The action is irreversible for the duration of the flight.
So if you're flying through a thick cloud with zero visibility and you turn off the IR switch, you suddenly have no idea which way is up or down.
Exactly.
That is terrifying. It makes perfect sense why that requires cross-confirmation.
Well,
It actually reminds me of a much lower stakes version of everyday life.
like what?
Think about typing out a furious email to your boss when you're upset. Hitting send is an irreversible control.
That's a great analogy.
Once it's gone, you can't unsend it. You really need a coworker to cross-check you before you click that button.
If we connect this to the bigger picture, you start to see the profound operational impact of this design.
How so?
In a highly automated cockpit, Airbus actively wants pilots to rely on the ECAM and the QRH to methodically process failures. They intentionally enforce that deliberate cross-checked pace because rushing leads to catastrophic, irreversible errors.
Like the email.
Exactly, but with much higher stakes. Let's say one of your engines suffers a severe failure and adrenaline is flooding your system.
Right.
If you rush, act on instinct, and pull back the thrust lever for the wrong engine, the healthy engine, you've just turned your jet into a 70-ton glider.
Oh, man.
The read-and-do philosophy prevents that impulsive, adrenaline-driven mistake by forcing the pilots to slow down, read the step aloud, physically point to the lever, and wait for their partner to say, confirmed.
The manufacturer is essentially telling highly trained professionals, do not trust your panicked brain.
Right.
Trust the screen, read the steps, confirm with your partner, and do exactly what it says. It imposes a massive speed limit on human reaction.
It does.
But as I was reading through this, I couldn't help but wonder about the obvious counter scenario. There are absolutely moments in aviation where physics will not wait for two pilots to politely cross-check a manual.
And the source text acknowledges that reality explicitly. The methodology shifts dramatically when time becomes the ultimate enemy.
Because the document highlights some genuinely scary situations. It mentions a rapid terrain closure rate, which is a very clinical way of saying a mountain's approaching your windshield extremely fast.
Yes.
It also mentions explosive decompression, where a hole opens up and you lose all your cabin pressure at 35,000 feet.
Another time-critical event.
In those specific moments, you obviously can't say, hold on, let me pull out the quick reference handbook. How does the Airbus philosophy handle a situation where there is zero time?
That is the exclusive domain of memory items.
Memory items.
The text defines these as procedures or very specific groups of actions that the flight crew must execute entirely from memory with absolutely no delay and without referring to any screens or books.
So it's pure reaction.
Yes. These are strictly, and I mean strictly, reserved for time-critical situations where the immediate safety of the flight or the structural integrity of the aircraft is at risk.
I love the visual detail the text provides about how these are displayed in the electronic pilot manual.
A white box.
Yes. To separate them from the hundreds of other procedures, memory items are visually highlighted inside a thick white box. If a procedure is printed inside a white box, it is no longer read and do. It has to live permanently in your brain.
I find it helpful to characterize these memory items as escape maneuvers.
Escape maneuvers. I like that.
They are pure survival actions. The pilot isn't trying to diagnose a complex systemic failure in that split second.
Right, they're just surviving.
Exactly. They're reacting to an imminent lethal threat. But to pull this off successfully, the pilot has to memorize not just the physical action, but the specific triggering conditions.
And the source gives a perfect example of this regarding a GPWS alert. That's a ground proximity warning system alert. Basically, the plane's computer shouting, "Pull up!"
Right.
The text specifies that this becomes a memory item if it happens during night flying or under IMC conditions. What exactly does IMC feel like to a pilot?
IMC stands for Instrument Meteorological Conditions. Think of it as flying inside a bottle of
Bottle of milk.
You're in dense clouds, rain, or fog, and you have zero visual reference to the outside world.
So you can't see the mountain.
If you get a sudden terrain warning shouting at you, and you can't look out the window to see how close the ground actually is, you don't pause to consult a checklist. The trigger condition has been met.
So you execute the memory item.
Instantly, you disconnect the autopilot, pull the stick full back, and apply maximum thrust. You escape the threat.
But once you pull up and avoid the mountain, what happens next? The text introduces a concept called the reversion principle, which seems incredibly important to keeping the cockpit organized.
It is a profound piece of the philosophy. A memory item might be a complete procedure in itself, like that terrain avoidance maneuver.
Right.
But in many cases, a memory item only covers the initial absolute protective actions.
Okay.
Consider that explosive decompression scenario. The memory item is to don your oxygen masks, establish communication, and initiate an emergency descent to get down to breathable air.
What you do from memory.
Exactly. Crucially, once you have neutralized that immediate life-threatening reality, the pilot must revert back to the standard read and do process.
So you survive the first 10 seconds using your memory, and then you force yourself back into the methodical cross-checked system to clean up the rest of the problem.
Yes. You don't just wing the entire descent based on what you remember from training.
That pivot requires so much discipline, which actually transitions perfectly into my absolute favorite section of this source material, the instructor's corner.
Oh, this part is great.
This is where we leave the sterile theory of the manuals and enter the simulator, where we get to see how human nature collides with this methodology.
The simulator observations are incredibly revealing. The instructors outline 3 very distinct, very insidious psychological traps that even veteran pilots fall into under stress.
Trap number 1 is called rushing the read and do.
A very common one.
The text notes this is the single most common error, especially for pilots transitioning to a new seat, like a co-pilot upgrading to captain or pilots returning from a long leave.
Right.
So picture the simulator. Alarms are blaring, red lights are flashing, an engine has just failed. The pilot's adrenaline is through the roof. What happens is the hero syndrome kicks in.
They want to fix it immediately.
They want to prove they are in control, so they start moving fast, trying to secure the broken engine from memory before the screen even tells them to.
And the text delivers a spectacularly blunt corrective for this behavior. It simply says, do not do this.
Just sit on your hands.
Literally.
I found myself thinking about this in the context of assembling IKEA furniture. We all do this.
Oh, absolutely.
We open the box, we see a bunch of wooden pegs and screws, and our ego says, I don't need the manual, I know what a bookshelf looks like. We rush the read and do.
And how does that usually end up?
30 minutes later, we have a bookshelf that leans to the left and 3 leftover screws.
Right.
That's annoying in a living room. But if you do that in an A320, you might shut off the wrong fuel valve.
Exactly. The instructors emphasize that if a procedure is not visually boxed as a memory item in your manuals, you must literally force yourself to do nothing.
It's so hard to do.
You must wait for the ECAM to present the diagnosis, and you must initiate the slow, methodical read and do process. The trap here is letting your ego or your biological stress response convince you that speed is more important than accuracy.
It feels completely counterintuitive. Your brain is screaming that there's an emergency, and the manufacturer is telling you that unless the plane is physically falling out of the sky, your very first action should be restraint.
Yes.
Now, the text outlines trap number 2, which is the exact inverse of rushing. It's hesitating on memory items.
This is the classic deer in the headlights trap.
The instructors observe that when a true time-critical event happens, like that terrain warning we discussed, or immediate actions dictated by something called an OEB cruise, sometimes freeze.
They do.
They sit there in the simulator, staring at the screens, waiting for the ECAM to give them a checklist, or waiting for the pilot monitoring to read the procedure out loud to them. Before we analyze the psychology of freezing, can you clarify what an OEB is?
An OEB is an Operations Engineering Bulletin. You can think of it like a critical software patch or a highly urgent safety bulletin from the manufacturer.
Okay, like a hot fix.
Exactly. It usually deals with a very newly discovered quirk or technical issue with a specific aircraft system that hasn't made its way into the permanent printed manuals yet. An OEB might dictate that if a specific bizarre combination of failures occurs, the pilot must take an immediate, non-standard action to prevent a crash.
So if you get an OEB situation and you sit there waiting for the normal screens to guide you, you are in serious trouble.
In any time-critical situation, hesitation is lethal. The philosophy dictates that you must know your white-boxed memory items and your OEB immediate actions flawlessly by heart.
No looking it up.
You cannot wait for a checklist when you have seconds to avert a disaster. You must recognize the specific trigger condition and execute the escape maneuver automatically.
It requires incredible mental flexibility to know which mode you're in.
It really does.
Because Trap 1 is acting from memory when you shouldn't, and Trap 2 is waiting for a checklist when you desperately need to act from memory.
Right.
But Trap 3 might be the most fascinating mental juggle of all.
Yeah.
The text calls it misunderstanding at any time items.
This trap perfectly illustrates the extreme dangers of cognitive overload in a crisis.
The source explores this trap specifically in the context of high workload, terrifying events, like a smoke or fumes procedure.
Right.
Imagine the cockpit is literally filling with smoke. You're wearing an oxygen mask, communicating is difficult, and you're running a massive multi-page read and do checklist to try and isolate where the fire's coming from.
It's a nightmare scenario.
The text notes that buried within these long procedures there are specific white boxes. But these aren't the standard escape maneuvers. They're labeled at any time items.
And what the instructors see in the simulator is that crews, driven by the intense stress and the heavy workload, develop extreme tunnel vision.
Just staring at the checklist.
They become so focused on reading the checklist line by line, trying to find the source of the smoke, that they read right past those critical at any time white boxes.
They get locked into the read and do mindset. They just want to execute the very next step in front of them.
But the content of an at any time box takes absolute priority over whatever step you are currently on.
Always.
The pilot is required to keep those specific conditions running in the back of their mind throughout the entire application of the procedure.
Give me an example of that.
For example, the box might say that if the smoke suddenly becomes dense enough to obscure the flight instruments, you must immediately drop the troubleshooting checklist and initiate an emergency descent to land ASAP.
Oh, wow.
If that condition is met, it completely overrides the linear checklist. You have to break out of the read and do trance and execute the action.
Think about the mental bandwidth that requires. It's like driving a car in heavy traffic while intently listening to your GPS give you complex turn-by-turn directions.
Right.
You have to follow the instructions carefully, but you also have to maintain a background awareness that if a deer suddenly jumps into the road and at any time condition, you have to ignore the GPS and slam on the brakes.
Exactly.
Doing that while a cockpit is filling with smoke is a staggering mental juggle. Which brings us to the final section of our deep dive today. The golden rules, and why everything we just discussed about pilot psychology is profoundly relevant to you, the listener.
The source document concludes by summarizing how this entire system logic, the strict divide between methodical read and do and split-second memory items, is a direct application of the Airbus golden rules for pilots.
And golden rule number 1 is famous in aviation. Fly, navigate, communicate.
Always in that exact order of priority.
Always. And the text points out that memory items exist purely to ensure the pilot continues to fly. When the flight path or the structural integrity is threatened, you don't worry about talking to air traffic control. You don't worry about programming the navigation computer.
You execute the memory item to keep the plane in the sky.
Exactly.
But the rule that I think bridges the gap between the cockpit and our everyday lives is golden rule number 4, workload management.
I love this part.
This raises an important question for you listening right now. How do you manage your own mental workload and your own memory when you are under pressure?
I found myself evaluating my entire work life while reading this section.
The document is very explicit. Airbus purposely restricts memory items to only the absolute most critical emergencies.
Yeah.
Everything else is relegated to a read and do process via the ECAM screens or the QRH.
And why do they do that?
They do this specifically to drastically reduce the memory burden on the flight crew.
By not forcing pilots to memorize 100 different complex technical procedures, the manufacturer frees up the pilot's brain power. It allows the crew to maintain better situational awareness and engage in methodical problem solving. It's a brilliant strategy. Keep it incredibly simple. Know the tiny handful of white box escape maneuvers by heart and rely on the checklists for absolutely everything else.
It is a profound institutional admission that human memory is fragile, especially under the influence of cortisol and adrenaline.
Yeah.
If a pilot's brain is desperately struggling to recall step 14 of a complex hydraulic failure procedure from memory, they simply do not have the cognitive bandwidth left over to notice that their airspeed is dropping dangerously low.
Offloading the memory burden actually makes you smarter and more observant in the moment.
It really does.
And think about how we apply or fail to apply that in our own lives. We constantly try to keep every single to-do list, every project detail, and every contingency plan for our jobs entirely in our heads.
We do.
We walk around carrying this massive, unnecessary memory burden. Then, the second a crisis hits at work or we get a stressful email, we are so cognitively overwhelmed that we end up shutting down the wrong engine, so to speak. We make impulsive, irreversible decisions because our brains are overloaded.
We fall victim to trap number one. Our adrenaline spikes during a stressful meeting, and we try to secure the situation from memory, speaking impulsively, instead of falling back on a methodical process.
We absolutely need to build our own read and do systems for our daily lives. If it's not a literal life or death emergency, if there's no rapid terrain closure rate happening in your office, we need to learn to sit on our hands.
Sit on your hands.
We need to consult our notes, gather the facts, cross-check with a colleague, and step through the problem methodically. We must save our mental memory items only for the rare things that truly require split-second action.
By heavily restricting what you demand your brain to remember during a crisis, you actually empower your brain to navigate that crisis with clarity and precision.
This has been such a revealing look at the architecture of problem solving. To summarize our key takeaways from this deep dive into the A320 mindset, the manufacturer has deliberately engineered a stark, life-saving contrast between two modes of operating.
Right.
You have the methodical, strictly cross-checked, read-and-do procedures for 99% of issues, ensuring accuracy over speed. And you have the split-second, instinctual memory items strictly reserved for immediate survival. The real danger, highlighted by the psychological traps in the simulator, occurs when human beings mix them up, when our egos rush a read-and-do, or when our fear causes us to hesitate on a memory item.
And as we bring this discussion to a close, I want to leave you with a final thought to mull over, building on the philosophy we've unpacked today.
Let's hear it.
Airbus spent billions of dollars to deliberately engineer a system that actively discourages highly trained professionals from relying on their own memory during almost all complex emergencies. They did this precisely because the data proves that human memory is deeply fragile and unreliable under stress. So ask yourself, if the pilots flying hundreds of people in complex machines are explicitly trained not to trust their memory to solve intricate problems, why do you so often try to navigate your own high-stakes personal and professional crises entirely from memory rather than building your own reliable read-and-do systems?
That is a phenomenal question to carry with you this week. Stop relying on your stressed-out brain, write down your procedures, and trust your process. Thank you so much for joining us on this deep dive into the A320 pilot methodology. We hope you discovered some valuable tools for managing your own workload, and we will catch you on the next one.